So welcome back to physics lesson. We'll continue that problem. We have now that is 6 joules energy stored in the combination. This is not the one. So 6 joules. So we have the first equation energy stored in the first combination in the first capacitor. That is something like 12 joule, right? So energy stored in the combination is 6 joule. So now you need to find out delta U, that's energy lost. Energy lost. Energy lost is equal to delta U is energy stored in the first capacitor minus energy stored in the combination, parallel combination. It's 12 joule minus 6 joule. You will get 6 joule. So here we need to know how to approach this kind of a question. When you see a question like this, where capacitor are connected in parallel after charging one capacitor. So first you find the energy stored in the first capacitor. Then you need to find out the parallel combination, effective capacitance of the parallel combination. So we got it as a something like 12 10 raised to negative 6, and energy stored in the first capacitor as a 12 joule. Very good. Then we found out the common potential difference between when they connected in the parallel. We got it as 100. Then we found out energy loss, energy stored in the combination as half times C times V square, and you got it as 6 joule. And finally, the energy lost, delta U, is equal to U1 minus UP, the 12 minus 6 joules. Simple, and we can go ahead with this kind of questions. And let me do the next question, which is again about the electric current. I can show it in the next slide. Is about the current in the electric circuits. So I'll show it in the next slide. Two cells of EMF 3 volt, 2 volt with the internal resistance 1.5 ohm and 1 ohm respectively are connected in parallel across 3 ohm resistors so that they tend to send current in the same direction. Calculate the potential drop across the 3 ohm resistor. Okay, we can see it in the next slide. Hope you can tackle, I can find a solution for this kind of problem. What you need is more practice. Practice questions of similar type and with a challenging one, and simple. Go from simple to challenging one. Whenever you have physics questions, don't try hard one first and challenging question one. You try very simple. You take time to solve initially, and then once you become practice, once you understand the concepts and know how to tackle the questions, then it's very easy, and I don't think it will be any more difficult for any students to challenge and to this question of this type. Okay, in the next slide I will show you the next question, and we'll solve it. So here is the next question. I'm going to put it in the next slide. Let me see the question here also, but explanation I do it in next class, next slide. This is over. So